All right, welcome back. This is Dr. Matthew J. Traum. This is video number 3 of lecture number 3 in the engineering design course. This is the slide we saw last time, so I will pick it up here. This again is Archer's three-phase design process model. And just to put this all in context again, we looked at a simple 4-step design model. We looked at Jones's design structure, and we looked at Archer's three-phase design process model. These are all just examples of the various design processes that have been suggested by various experts throughout the history of design. And the point is not that you're going to be using any of these processes, but simply to show that they have commonalities. And so if you dig into the textbook a little bit, you'll see that there are some significantly more complex suggested design process models, but I'm not going to talk about those in the lectures because well, they just get so complex at a point that they begin to convolute the important steps of the design process. So what we're going to do in looking at these three simpler models is to extract commonalities, and then I'll describe those commonalities in the next slides so that you can see what's common among all suggested design processes. So if I go back one slide, there we go, saw this structure of Archer's three-phase design process model, and I described briefly what each of these activities represents, but the purpose of this slide is to put a little more detail into those descriptions. So in the analytical phase, there's two stages: programming and data collection. Programming is where you establish the crucial issues and propose a course of action. Data collection is collecting, classifying, and storing data. So again, in an engineering design process, we would think of that as developing a set of customer needs, a customer needs statement, design constraints, and then trying to quantify all of those constraints and customer needs into some sort of numerical or quantitative or equation-based form. So the second phase then is the creative phase, and this includes 3 stages: analysis, synthesis, and development. Analysis is identifying subproblems and preparing the design. Synthesis is preparing an outline of the design proposals, and development is to develop prototype designs, preparing and executing validation studies. So there's a lot in this phase, but it's essentially the brainstorming step where you come up with all of the possible solutions that could solve your particular design problem, and then you evaluate, you down select from all the possible solutions to the very small handful of solutions that are viable and the best, that appear to be the ones that would be the most promising to solve your particular engineering design problem. And then the development of prototypes and the testing of prototypes to validate your thinking when you did the down selection and the quantitative analysis that was in the previous stages of the creative phase. To, you've got a working prototype now just to make sure that you were right in your analysis. And then finally the executive phase, which has one stage which is just communication, and that's preparation of the manufacturing documentation. Again, remember, the purpose of any design process is to communicate to the person who's ultimately doing the fabrication or the manufacture of the artifact what artifact that person is meant to manufacture. So that's that final executive phase. It's just explaining, typically from an engineering perspective through engineering drawings, how to create this object that you've just designed. Okay, so now that we've looked at those 3 different suggested processes, we're going to extract from them 7 commonalities. So these are attributes of all model engineering design processes, regardless of how complex those processes become. So the first one is to establish the design requirements, and this must happen first, so you know what the problem is that you're actually trying to solve. The second attribute is that there is no direct path from the problem to the solution. So as we saw in the very first example, there was that arrow going back up in the wrong direction, just to remind us that This is not a hierarchical or linear process that sometimes you learn something late in the process that informs a decision that you would have made earlier on, and so you do have to backtrack. Third is understanding the problem and the solution develop together. So that's another way of saying essentially what I just said, that the more that you learn about the solution and the more that you think about the solution, the more clear the problem becomes, and the problem could actually change as you learn more about the solution. So those two things are intertwined. Number 4 is that the designer's attention constantly oscillates between the problem space and the solution space. So as you're developing solutions, you'll find in all of these models that it's encouraged to go back and look at the problem and make sure that you've actually framed the problem correctly. A lot of times the best design solutions are realized by changing the initial wording of the design problem. Number 5 is each process step is connected to a previous step and a next immediate step. So that was those arrows that we saw in the first model that connect all the steps to one another. None of the steps are orphaned or isolated out on their own. They're all interconnected, but it is of course essential to backtrack and be able to and be comfortable with backtracking through the process. Number 6 is that iteration must occur to converge upon the best design solution. So you are going to need to backtrack. You're going to come up with a solution that teaches you more about the problem than you knew before, and it might actually change the problem, causing that solution that you thought was so great to be discounted. So you're going to have to iterate through this process a number of times to converge to the best possible solution. And then finally, the building and testing of prototypes is essential to validate the design process before moving into manufacturing. So I'm an experimentalist. I am a big fan of building and testing working prototypes. I think no matter how good your modeling is or how good your design process is, you cannot know for sure that the object or the artifact that you've designed will work as expected unless you build a prototype and test it. So from the 3 models that we've looked at, we extract all of these commonalities, and the commonalities lead to the next slide, which is our stepwise engineering design process. Now, I've just gone over 7 minutes, so I'm going to stop here and have you guys take another break, and we will pick it up again when you are ready in just a few moments. See you soon.